number 4 from the Unit 2 free response review. There's already a video where I go over the first 3. So this is a new one that I've added on, trying to do more emphasis on free response questions so you guys a better chance to be successful in May on the AP exam. So here we go. We're looking at essentially a scatter plot that shows you the number of wins and the attendance per game for 30 baseball teams in 2017. All right, so basically they're saying the number of wins is going to explain the attendance per game. That kind of makes sense as someone who watches baseball. Usually the teams that are playing well and winning are going to have more people attend those games. The teams that are playing poorly or not set up to win games are going to have less people turn out for the game. So interpret the slope of the least squares regression line in context. So I want to go ahead and I'm going to write down underneath this table in the computer output, I'm going to write down the actual linear regression model, but understand that you don't have to do this step. I'm just trying to show you kind of where to pull all this stuff from. So the Y value is attendance. Oh, let's get something that's not a highlighter. Sorry about that. The Y value is attendance per game. So I'm going to put hat equals my constant, which is 10,834 plus 235 times the number of wins. All right, so when it's asking for you to interpret the slope, you first need to make sure you identify the slope. So the slope is 235. All right, that's the first thing you want to do. And then to interpret it, we're saying that if a team wins one more game, I would expect the average attendance to increase by 235 people. All right, so that is identifying and then interpreting the slope. It doesn't actually ask you to interpret the y-intercept, right? So this was the slope, here's the y-intercept. But if it did ask me to interpret the y-intercept is 10,834. So we're saying a team with 0 wins, right? I would expect to average 10,834 people per game in attendance. Now, we're going to get to a moment why that could be potentially an issue here. So it says, explain why it is not reasonable to use the least squared regression model to predict attendance per game for 0 wins. So essentially this is asking about the y-intercept, right? And there's a couple of reasons why it's not okay to use this linear regression model. I think one thing is, as a person who watches baseball and has watched baseball for a while, I've never seen a season where a team has won 0 games. I don't know the lowest I've seen, but I think even the worst teams usually get to 50, 60 plus wins, as you can see here, the minimum being, I think, about 64 wins in 2017. But the key thing is if the lowest value is 64 in terms of the number of wins or your X values, and the highest looks like is, I'm going to say 104. I have to Google it, but I think that was the Dodgers that year. Essentially, if I want to use this model, I need to be using values between 64 and 104. If I move past that, whether it's above 104 or less than 64, that would be what we call extrapolation. So when you say why it's not reasonable, it's not reasonable because 0 is not between the lowest, which was I think 64, and highest, which I think was about 104, number of wins. Right? We've mentioned this before that you just want to be careful that you're only using values that are in between the values that you actually have to create your model. Okay, what is the value of the correlation coefficient in the sample? Now, it doesn't actually give us the letter R. This is asking about lowercase letter r, but it does give us r squared. So it says r squared is 12.29%. So let me just write that down. r squared is 12.29%. So what I'm going to do is I'm going to go to my calculator, and I am going to take the square root of r squared. All right, so I'm going to do the second square root of 0.1229, which is roughly 0.351. So the correlation coefficient is 0.351. Now, just want to make a point here, it didn't end up mattering in this one because you can see by this linear regression line or model that it has a positive slope. You can see the shape of the scatter plot is showing slightly positive there. But just keep in mind, right, if they give you r squared, which they did here, that's going to cover up any potential negatives, right? Because when you square a negative, you get a positive. So just be careful here. If this had shown, if it had shown like the model having a line going negatively, then I would have to make sure that my r is a negative. So just take that 5 seconds to just ask, is this going to be a positive, right? And look back at your scatter plot to see if you have to actually throw in a negative. But we don't, r is positive, and that's definitely weak. Okay, last part. If the point representing 64 wins and attendance of 40,786 people per game, so that looks like this point here, is removed, and they basically redo everything, how would the following be impacted, and explain your reasoning? So the slope of the least squares regression line. So you can't see it, right, because I'm not showing you what I'm doing, but essentially with my hand, I'm covering up that line or that dot because I'm taking it out. And so my thought is if I take that out, it's going to end up probably making my line maybe just a little bit steeper, right? Maybe that's a little too much, but it does look like the direction would be slightly more positive. And so my slope would have to increase because the line is a little bit steeper. So I'm going to put that the slope would increase because without that point, the direction is slightly more positive. All right, so it's going to have to make my linear regression line, when I sketch it, would be a little bit steeper, so the slope would have to go up. The correlation coefficient. So the idea here is if you look at, same thing, I'm covering it with my hand, but when I look at that point, it does make it, when it's in there, it makes it look more cloud-like, and when I cover it up, it looks, in theory, should be less cloud-like. So it should be, even though you're not really changing a whole lot, it should, in theory, make this linear relationship be slightly stronger because it's going to be, more of a linear form. So I'm going to put that the correlation coefficient would increase because taking this point out makes the form less like a cloud, or I'll say, or slightly stronger. All right, so that's what I'm putting for that last question. So again, if you haven't watched the video for 1 through 3, check that out. But in terms of what you're going to expect on the test for the free response section, you're going to have questions like this, and I'm going to make it challenging. There's going to be 3 of them, but you're going to have to work quickly. So you got to make sure you know what you're doing to answer all this stuff about linear regression, okay? So good luck on the test.